Tamarillo, often called the tree tomato, not because it looks like a tomato on a vine, but because Tamarillo grows as a small fruit tree with a woody stem, a permanent structure, and a lifespan measured in years, not seasons. Here is the paradox. A single Tamarillo plant can begin producing fruit in its first year, then continue yielding for 5 to 8 years, sometimes longer, without being replanted. In climates where it is established, one Tamarillo tree can produce 20 to 30 kilograms of fruit per year, repeatedly from the same root system. That number matters, because it is not a record, it is not a laboratory result, it is simply what Tamarillo does by nature. And yet, despite this, Tamarillo is almost absent from modern food culture. Not just supermarkets, but seed catalogs, school gardens, and basic agricultural education. Today, tomatoes are replanted every year. Seeds are bought every year. Beds are cleared every year. Tamarillo breaks that rhythm. By design, Tamarillo does not reset itself annually. It does not require a yearly restart. It keeps going, which raises a quiet but unavoidable question. If Tamarillo can produce fruit for years from a single planting, why is it treated as a curiosity instead of a staple? Why is a plant with a multi-year yield cycle almost invisible, while annual tomatoes dominate gardens across entire continents? This is not because Tamarillo is fragile. In New Zealand field trials conducted in the mid-20th century, Tamarillo was explicitly described as a productive perennial fruit crop, valued for its extended harvest window and structural permanence. It was studied, named, standardized. The plant existed clearly enough to be classified and then quietly stepped around. Today, Tamarillo still grows, in backyard orchards, on the edges of farms, in places where food is grown for continuity, not turnover, which makes the contradiction sharper. A fruit tree that behaves like a tomato but refuses to behave like an annual crop. Tamarillo did not disappear because it failed. It became unfamiliar because it never fit cleanly into the cycle that replaced it. And that cycle, the one that depends on repetition, replacement, and reset, is what turned Tamarillo from a solution into an afterthought. This is the story of Tamarillo, not as a forgotten novelty, but as a plant whose very biology placed it outside the model that came to define normal. Long before Tamarillo appeared in agricultural reports, it already had a place in daily life. In the highland regions of Ecuador and southern Colombia, Tamarillo was not planted as a seasonal vegetable. It was grown beside homes, along garden edges, and near paths, treated as a small fruit tree expected to remain in place for years. Local records and ethnobotanical surveys from the early 20th century describe Tamarillo as a household food source, not a market crop. Families did not plan their year around planting Tamarillo. They planned their meals around the fact that Tamarillo would still be there. The fruit was harvested fresh, cooked into sauces, or preserved. But the key detail is not how Tamarillo was eaten. It is how Tamarillo was relied upon. Unlike annual tomatoes, Tamarillo did not mark time by seasons, it marked time by continuity. That same quality is what drew attention far from the Andes. In the late 1940s and early 1950s, agricultural researchers in New Zealand began formally evaluating Tamarillo as a fruit tree suitable for temperate climates. By 1967, the name Tamarillo itself was officially adopted to distinguish the plant from common tomatoes and to position it as a tree fruit rather than a garden vegetable. Government-backed trials described Tamarillo as fast establishing structurally permanent and capable of extended production. Once planted, Tamarillo entered a predictable rhythm, flowering, fruiting, resting, then repeating. What mattered was not peak yield. It was the absence of gaps. For growers observing Tamarillo, the plant reduced one major uncertainty: the need to start over. No annual seed decision. No empty bed waiting to be replanted. No reset built into the calendar. And yet, even during this period of formal study, Tamarillo was framed narrowly. It was discussed as an alternative fruit, a specialty crop, something to test, not something to reorganize food production around. That framing mattered, because Tamarillo was already demonstrating a different logic, a logic where productivity was spread across time rather than concentrated into a single harvest window. where stability mattered more than turnover. In household gardens, Tamarillo functioned as a standing asset. Once established, it asked little and returned regularly. That is why its historical use is important. Not because Tamarillo was everywhere it wasn't, but because wherever Tamarillo was grown, it behaved consistently long-lived, repeat-producing, and resistant to being reduced to a seasonal input. This is not a story of a plant that failed to prove itself. Tamarillo proved itself quietly in places where food was measured by reliability, not scalability. And that proof spread across backyards, hillsides, and research plots set up the question that follows. If Tamarillo worked and worked predictably, why did its presence stop expanding even as annual tomatoes spread faster than ever? To understand why Tamarillo behaves so differently, you have to look at what Tamarillo is not as a fruit, but as a system. A tomato plant is built to rush. It grows fast, fruits once, and collapses. Its biology assumes replacement. Tamarillo is built for persistence. From the moment Tamarillo establishes a woody stem, its priorities change. Energy is no longer spent rebuilding structure every season. Roots deepen, branches harden. Each growth cycle adds to what already exists. That single shift changes the mathematics. With annual tomatoes, yield is tied to repetition. Every kilogram of fruit depends on new seedlings, new soil disturbance, and a fresh round of inputs. With Tamarillo yield compounds across time. If one Tamarillo tree produces 25 kilograms of fruit in a year, a conservative figure reported in mid-century New Zealand trials, that number does not reset the following season. The same tree produces again and again. Over 5 years, Tamarillo does not produce 25 kilograms. It produces over 100 kilograms without replanting. That is the number that matters, because the input curve does not rise with the output curve. Once Tamarillo is established, the work shifts from creation to maintenance. This is not a technical advantage, it is a biological one. Tamarillo does not need to be restarted. That single fact places Tamarillo outside the logic of annual agriculture, where productivity is measured per season, not per lifespan. In economic terms, Tamarillo compresses labor into the beginning and stretches returns into the future. Annual tomatoes do the opposite. They distribute labor every year and require constant renewal. Nothing about this makes Tamarillo fragile. In fact, perennial structure gives Tamarillo resilience, the ability to recover from short-term stress without total loss. But resilience creates a problem. Because systems built around yearly turnover depend on predictable resets. They depend on seeds being bought again, beds being cleared again, decisions being repeated again. Tamarillo interrupts that rhythm. Not dramatically, not loudly, quietly by continuing. This is why Tamarillo was difficult to standardize. Its productivity could not be cleanly sliced into annual charts. Its value accumulated slowly across seasons that modern accounting treats as separate events. From the perspective of long-term food security, Tamarillo's efficiency is obvious. From the perspective of short-cycle production models, Tamarillo is awkward. It does not fail fast, it does not restart cleanly, it does not encourage replacement. And because Tamarillo's advantage is temporal, not immediate, it rarely shows up where decisions are made in one-year increments. By the time Tamarillo proves its value, the model has already moved on. That is the core mechanism. Tamarillo works by refusing to hurry, and that refusal is precisely what begins to push Tamarillo out of alignment with the system that comes next. The real value of Tamarillo does not appear in yield charts, it appears in a household. A family that plants Tamarillo does not mark the calendar waiting for the next sowing. They mark time by return. Once established, Tamarillo becomes a fixed presence in the yard. It stands where it was planted season after season, producing without being rebuilt. There is no empty bed, no restart. That changes behavior. With annual tomatoes, planning begins with absence. Seeds must be chosen, soil must be turned, time must be reserved every year just to recover what was already available before. With Tamarillo, that absence never arrives. A mature Tamarillo tree produces fruit over an extended window. Not all at once, not in a single rush, but in waves. That matters at the household scale. Because food that arrives gradually is used differently. It is cooked fresh, preserved without urgency, shared without the pressure of spoilage. The family does not ask how to maximize Tamarillo. They ask how to keep up with it. The key advantage here is not abundance, it is continuity. A single Tamarillo tree can bridge seasons. It smooths the gaps between plantings that annual crops cannot avoid. When other beds are empty, Tamarillo is still there. This changes the meaning of security. Not emergency survival, not stockpiling, but knowing that food production did not reset when the season changed. In practical terms, Tamarillo reduces decision pressure. There is no yearly debate about whether to plant again, no calculation about whether conditions are right this time. The decision was already made years ago when Tamarillo was planted. That is the peak value. Tamarillo converts a choice into a condition. Once it exists, it quietly keeps working. At this scale, Tamarillo behaves less like a crop and more like infrastructure. It does not demand attention to justify itself. It simply occupies space and produces. This is why Tamarillo makes sense where continuity matters more than output spikes. Backyards, homesteads, places where food is expected to be present, not scheduled. But this same quality creates friction, because systems designed around annual cycles measure success by how often activity repeats. They reward planting, clearing, and replacing. Tamarillo does not participate in that rhythm. Once mature, Tamarillo requires less intervention, not more. It does not stimulate recurring transactions. It does not create seasonal urgency. Its value accumulates quietly without signaling. And that is precisely where Tamarillo reaches its highest usefulness and begins to drift furthest from the models that define modern efficiency. The problem with Tamarillo was never performance, it was alignment. As agriculture shifted toward models that depended on annual cycles, Tamarillo began to fall out of step, not because it stopped producing, but because it produced without resetting. Modern production models organize time into seasons. Seeds are selected, sold, planted, harvested, and cleared, then the cycle repeats. Value is measured per year. Decisions are revisited annually. Tamarillo does not fit that structure. Once a Tamarillo tree is established, there is no seasonal restart. There is no annual re-entry point where choices must be made again. The plant simply continues. From a planning perspective, Tamarillo collapses multiple years into one decision. Plant once, then wait. That creates a mismatch. Annual systems depend on predictability through repetition. They depend on standardized timelines and synchronized harvests. They reward crops that can be planted and replaced on command. Tamarillo resists standardization. Its fruiting window stretches. Its maturity varies slightly by climate and age. Its productivity accumulates across years instead of peaking once. None of this makes Tamarillo unreliable. It makes Tamarillo difficult to schedule. In large-scale planning, that distinction matters. A crop that produces steadily but unevenly is harder to fold into centralized distribution. A plant that does not require yearly replacement generates fewer moments of transaction. A tree that stays in place resists being treated as a consumable input, so Tamarillo was categorized differently. Not rejected, not removed, simply placed at the margins, labeled as a specialty fruit, a backyard curiosity, an alternative. In extension manuals and commercial guides, Tamarillo appeared briefly, then faded. It was never positioned as a default choice, never framed as foundational. Meanwhile, annual tomatoes expanded rapidly precisely because they matched the cadence of the system. They fit into rows that could be cleared. They aligned with seed schedules. They reset cleanly. Tamarillo did not fail to compete. It competed on a timeline the system did not measure. Over time, what could not be easily integrated became easier to ignore, not through force but through omission. And omission has consequences, because when Tamarillo stopped being included in standard models, it also stopped being taught, recommended, and remembered. The shift was subtle. Tamarillo moved from being a viable option to being an exception, and then eventually to being unfamiliar. That is the turning point. Not a moment of removal, but a moment of misfit. Tamarillo did not change, the model did. And once that happened, a plant designed to last quietly lost its place in a system designed to restart. The disappearance of Tamarillo did not begin in fields. It began in ordinary places. In school gardens, children learn what food plants are supposed to look like. Short, seasonal, removed at the end of the year. Tamarillo is not there. The absence matters because learning is visual before it is conceptual. When Tamarillo is not seen growing year after year, the idea of a tomato-like fruit as a permanent tree never forms. In seed catalogues, Tamarillo rarely appears beside common tomatoes. When it does, it is separated, placed among exotic fruits labeled as unusual, optional, advanced. That separation teaches something quietly. It teaches that Tamarillo is not normal. Garden centers reinforce the same pattern. Tomato seedlings arrive every spring in rows, synchronized and replaceable. Tamarillo, when present at all, appears as a single potted tree, not part of a cycle, but an exception to it. Over time, this reshapes expectation. When people think of growing tomatoes, they think of starting over. They think of clearing beds. They think of buying seeds again. They do not think of Tamarillo because Tamarillo does not fit the picture they were shown. This is how knowledge disappears not through erasure, but through normalization. Once Tamarillo stopped being present in everyday growing spaces, its absence became invisible. People did not decide against Tamarillo. They simply never considered it. A plant that once stood in gardens for years became something that had to be searched for. And when something must be searched for, it stops being part of what feels reasonable. This is the quiet effect of omission. Without Tamarillo in view, the annual reset begins to feel natural. Replanting feels inevitable. Replacement feels efficient. The idea that a tomato-like fruit could persist for years starts to sound unrealistic, not because it is untrue, but because Tamarillo is no longer present to contradict it. What was lost here is not just a plant. It is a reference point. Without Tamarillo, people forget that continuity was once visible. They forget that food plants did not always demand repetition. They forget that permanence was an option. And once that forgetting settles in the system, no longer needs to argue its case. The absence of Tamarillo does the work for it. Despite its absence from most fields and catalogues, Tamarillo never disappeared. It simply stopped being visible. Today, Tamarillo still grows in places that operate outside standardized cycles. In backyard orchards where planting decisions are made once and lived with for years. In botanical collections that preserve fruit trees, not for scale, but for memory. In small farms where continuity matters more than uniform timing. In these places, Tamarillo behaves exactly as it always has. It establishes, it holds its ground, it produces again. What is striking is not that Tamarillo survives. It is that Tamarillo survives without adaptation. No redesign, no genetic rescue, no reinvention. The plant itself never changed. Where Tamarillo is still grown, it is treated as a tree, not a crop. It is pruned, not replanted. Maintained, not replaced. That distinction preserves the knowledge. People who live with Tamarillo understand its rhythm intuitively. They do not ask how to restart it. They ask how to support it. This knowledge is rarely written down. It is transmitted through presence, through seeing Tamarillo fruit again on the same branches year after year. In some regions, Tamarillo has quietly re-entered local markets as a specialty fruit. Not scaled, not standardized, but recognized. These reappearances are small. They do not announce a comeback, but they serve an important function. They prove that Tamarillo was never incompatible with reality. It was only incompatible with a particular way of organizing time. Outside that framework, Tamarillo makes immediate sense. Its long life is not a drawback. Its irregularity is not a flaw. Its persistence is an advantage. This is what recovery looks like. Not revival through expansion, but restoration through recognition. The knowledge surrounding Tamarillo does not return as instruction manuals or campaigns. It returns as familiarity, the quiet understanding that this plant exists and works and always has. Once seen again, Tamarillo does not need to be defended. Its continued presence is the argument. When Tamarillo is seen again, not as a novelty, but as a living plant, something subtle changes. The question is no longer whether Tamarillo is better than tomatoes. That comparison begins to feel incomplete. What Tamarillo alters is the frame. For decades, efficiency has been understood as speed, faster growth, faster harvest, faster replacement. But Tamarillo introduces a different measurement: time without interruption. A plant that produces once, then asks to be replaced, fits a certain logic. A plant like Tamarillo, which continues producing from the same structure year after year, fits another. Neither is imaginary, both are real. The difference is which one became normal. When Tamarillo was present, continuity was visible. When Tamarillo faded from view, replacement took its place quietly without debate. Seeing Tamarillo again exposes that shift. It reveals that annual replanting was not the only option, but the option that aligned best with short-cycle thinking. Tamarillo does not argue against modern systems. It does something simpler. It stands there unchanged producing and reminds us that permanence once existed alongside productivity. That reminder reframes words like efficient, safe, and practical, not as absolutes, but as choices shaped by models. Tamarillo does not demand adoption. It does not promise rescue. It only restores a missing reference point. And with that reference restored, it becomes harder to believe that what we see today is the only way food has ever worked, or the only way it ever can. Tamarillo remains what it has always been, a tree that fruits like a tomato, a plant that refuses to reset. The change happens elsewhere, in how we recognize value, in how we understand normal, and in how easily a working solution can disappear, not because it failed, but because it lasted.